Assalamu alaikum. We are discussing S and P block elements. We are discussing S and P block elements for F.Sc part 2. Today's topic is physical properties of the oxides of period 3, of oxides of period 3 elements. In this context, we will study the structure of oxides. Second, the melting point and boiling point of oxides, and electrical conductivity of oxides. Now, the oxides of period 3 oxides are sodium can form sodium oxide and sodium peroxide. Magnesium forms only normal oxide, which is MgO. Aluminium forms aluminium oxide, Al2O3 or alumina. Silicon forms silicon dioxide or silica. Phosphorus can form P4O10, phosphorus pentaoxide and phosphorus trioxide. Sulfur can form sulfur trioxide and sulfur dioxide, and chlorine can form chlorine heptaoxide and dichlorine oxide. Argon do not form any oxides. Now we study the first property, which is the structure of these oxides. As we move from left to right, we are moving from ionic to covalent to discrete molecules. The oxides of sodium oxide and magnesium oxide, they consist of giant molecules consisting of ionic lattices. They consist of very big molecules having ionic lattices. The oxides of alumina, silica, the oxides of alumina and silica, they consist of giant molecules, big molecules with covalent bonds. They have covalent bonds. Rest of the oxides, that is oxides of phosphorus, phosphorus pentaoxide, phosphorus trioxide, oxides of sulfur and chlorine, they either consist of discrete molecules or dimeric structures. SO3, SO2, Cl2O7 and Cl2O, they consist of discrete molecules, separated molecules. P4O10 and P4O6, they are dimeric in nature. So when we move along period 3, the nature of oxides changes from ionic to covalent, giant ionic to giant covalent, and then discrete molecules. The second property of these oxides is melting point and boiling point. We know that melting and boiling is nothing but the separation of molecules from each other. In melting, solid molecules in the solid phase, they go away from each other, it changes into liquid, and in boiling, the liquid molecules, they go away from each other. The melting point and boiling point depend upon two main factors, that is the size of molecule and the intermolecular attractive forces. As the size of molecules increase, melting point and boiling point will also increase. Similarly, as the intermolecular attractive forces increase, the melting point and boiling point will increase, or vice versa. Now, if we consider the trends in period 3 elements, in the oxides of period 3 elements, We know that the oxides of sodium and magnesium, they consist of very large molecules, giant molecules having stronger attractive forces, which are known as ionic bonds. That is why the oxides of sodium and magnesium, they will have very high melting point and boiling point. Now when we move to alumina and silica, the size of molecules is same. They also consist of giant molecules, but the attractive forces decrease because they have covalent bonds which are weaker than ionic bonds. That is why when we move forward towards silica, the melting point and boiling point will decrease. And as we move forward, we get molecules which are small, are dimeric, and they have weak forces which are known as van der Waals forces. As we are moving forward, the size of molecules is decreasing as well as the attractive forces are decreasing. Therefore, the melting point and boiling point will decrease. Thus, we can say that generally as we move along period 3, the melting point and boiling point of oxides decrease. The third property of oxides of period 3 is electrical conductivity. Electrical conduction is either due to the presence of free electrons or it is due to the presence of mobile ions. All the oxides of period 3 in solid state, they have neither free electrons, no free electrons, and no mobile ions. No movable ions are present. That is why in solid state all oxides are non-conductors of electricity. However, the metallic oxides are such as sodium oxide and magnesium oxide. The metallic oxides consisting of ionic lattices like oxides of sodium such as sodium oxide and sodium peroxide, and oxide of magnesium, magnesium oxide, they become conductors in molten state. They become conductors in molten state. The fourth property of these oxides is acidic and basic nature of the oxides. We are also discussing the fourth property, which is the acidic and basic nature of oxides of period 3. The fourth property of these oxides is acidic and basic nature of oxides. It is a general rule that metal oxides are usually basic in nature. For example, sodium oxide and sodium peroxide and magnesium oxide, they are basic in nature. They dissolve in water and produce strong alkalis, strong bases. Alkalis are the bases which readily dissolve in water. So when they are dissolved in water, they produce strong alkalis. Like sodium oxide plus water, it produces sodium hydroxide solution 2NaOH. Similarly, sodium peroxide plus water, it produces a 2NaOH plus hydrogen gas. Magnesium oxide plus water, it produces magnesium hydroxide. As these oxides of sodium and magnesium, they dissolve in water and produce an alkali. Therefore, these oxides are also called basic anhydrides. Basic anhydrides. Anhydrides are the compounds which contain no water. They contain no water, but when they are dissolved in water, they produce strong alkalis. That is why they are also known as basic anhydrides. Due to basic nature, these oxides will react with acids and produce salts. For example, sodium oxide will react with 2HCl hydrochloric acid to produce sodium chloride, salt plus water. Now we come to aluminium oxide. Aluminium oxide is amphoteric in nature. It means that it shows both the acidic property as well as the basic property. It shows acidic property and it can react with strong alkalis like sodium hydroxide, 2NaOH, to produce salts which are called aluminates. We get 2NaAlOH4. Al2O3 plus 2NaOH plus 2H2O, we get the salt which is known as sodium tetrahydroxo aluminate 3. Similarly, aluminium oxide can also show basic nature and it can react with acids like Al2O3 plus 6HCl. It reacts with hydrochloric acid to produce 2AlCl3, a salt, and water. Rest of the oxides such as silicon dioxide, oxides of phosphorus, sulfur and chlorine, they show acidic behavior, and when they are treated with water, silicon dioxide is acidic in nature. Aluminium oxide does not react with water. It reacts with strong acids, but it does not react with water. Similarly, silicon dioxide is acidic in nature, but it does not react with water. It can react with strong bases and produce salts which are known as silicates. For example, we have silicon dioxide plus sodium hydroxide. We strongly heat the mixture of sodium hydroxide and silicon dioxide so that we get sodium silicate plus water, Na2SiO3 plus water. Rest of the oxides such as phosphorus trioxide P4O6, phosphorus pentaoxide P4O10, sulfur trioxide, sulfur dioxide and oxides of chlorine Cl2O7, all of them are acidic in nature. They react with water and produce acids. For example, P4O6 phosphorus trioxide, it reacts with water and produces phosphorus acid, orthophosphorus acid H3PO3, 4H3PO3. We will balance this equation. We have 12 hydrogen, therefore it will react with 6 water molecules. We have 12 oxygen and here we also have 6 plus 6, 12 oxygen, 4 phosphorus and 4 phosphorus. So P4O6 react with water to produce phosphorus acid or orthophosphorus acid. Phosphorus acid. P4O10 also react with water and produces phosphoric acid H3PO4, orthophosphoric acid 4H3PO4, 6H2O. Sulfur trioxide reacts with water and produces sulfuric acid H2SO4. Sulfur dioxide reacts with water and it produces sulfurous acid. Chlorine heptaoxide, dichlorine heptaoxide, it reacts with water and produces hypoperchloric acid HClO4, 2HClO4, perchloric acid. As these oxides, they are reacting with water and they are producing acids, hence these oxides are also known as acidic anhydrides. These are the compounds which contain no water, but when they are dissolved in water, they produce acids. Now, as they are acidic in nature, therefore they will also react with bases. The general trend of the oxides acidic basic behavior along the period is that when we move from left to right in the period 3, we are moving from basic oxides to amphoteric oxides, and then acidic oxides. Thus the trend of nature of oxides changes from basic to amphoteric to acidic. The reason is that in the period 3, when we move along the period, we are moving from metals to metallides and non-metals. Metal oxides are usually basic, oxides of metallides may be amphoteric, and the oxides of non-metals are always acidic in nature.